Hello and welcome to the University of Sussex. My name is Simon Peters and I lead the group on the Deep Underground Neutrino Experiment, or DUNE. The experiment is located in the US and will study the properties of neutrinos. What keeps our group awake at night is that everything around us is made out of matter. What happened to the antimatter? Neutrinos might hold the key to solving this puzzle.
Antimatter is exactly the same as matter, except it has opposite electric charge. So when a matter and antimatter particle come together, they annihilate into energy. So our theory of the standard model tells us that at the beginning of the universe there was equal amounts of matter and antimatter created. But in the world today, everything's made out of matter. So we're trying to understand what new physics could be out there to help us understand that asymmetry.
DUNE is a huge international experiment. It spans 1,300 kilometers. We create a powerful neutrino beam starting at Fermilab, which we fire through the Earth all the way to South Dakota. So these neutrinos are then detected in an enormous lab 1.5 kilometers underground in 4 60-meter detectors. The UK are leaders in building the experiment and the data acquisition system for DUNE. At Sussex, we lead the UK data acquisition effort.
When a neutrino interacts with a detector, it can generate charged particles. And as these fly out from the interaction point, they leave a trail of charge. This charge is then collected on a grid of wires, creating tiny electric signals that are read out by the data acquisition system. This data is then used to reconstruct the trajectories of the charged particles coming out from the interaction point.
This is an FPGA board. It's an electronics board we use in DUNE to acquire data and signals from the detectors. This one specifically we're using to develop here at Sussex the firmware and software that we're going to be using to read out data from a prototype detector. In the real system, you will require hundreds of these boards to acquire data from all signals in the detector at the same time.
The amount of data DUNE will handle is equivalent to streaming 400 high-definition movies per second for one detector, or 1,600 for 4 detectors. That's almost 60 billion movies per year. We can only store 12 million movies per year, so we needed to sift through the data live and select the information we want to keep. That's about 1 out of 5,000 movies. And DUNE can do this using the software that our group is developing.
So once we have this raw data, we are using standard and machine learning algorithms to translate this into real physical properties, like types of particles, types of interactions, their energies. And you can see an example of some particles and their interactions in one of our detectors. And by comparing neutrino and antineutrino interactions, we are hoping to uncover what is really behind the matter-antimatter asymmetry in the universe.
DUNE can also detect neutrinos that don't come from Fermilab. One example of the source is exploding stars inside our galaxy. These neutrinos have much shorter trails, which means they can get lost amongst the backgrounds. It's a bit like having a recording of a crowd of people all talking at once when you're trying to listen to just one person. If you can understand each person, what they're saying, you can start to filter out the background noise. Here at Sussex, we're trying to understand the backgrounds to be able to filter them out and really listen to what the neutrino is trying to say.
Another source of neutrinos is the Sun. These solar neutrinos are produced by fusion reactions inside the Sun's core. In addition, evidence suggests that our universe is filled with a mysterious substance called dark matter. It is called dark because we have not been able to observe it directly. And as our Sun travels through the galaxy, it might be sweeping up this dark matter and capturing it using its gravity. This dark matter could reveal itself by producing higher energy neutrinos, in addition to the solar neutrinos. detecting them at DUNE will be key to unlocking the mystery of what dark matter truly is.
As a new PhD student at Sussex, I'll be working on the trigger at DUNE, and I'm really excited because I get the opportunity to work with a lot of different people who come from a lot of different backgrounds and scientific disciplines, and the prospects of DUNE and the science it could provide is really, really exciting for me.
We are working really hard with colleagues from around the world to make discoveries that could change the way we think about the universe. That's all from us at Sussex. Thanks for watching.